Cement is the essential binding ingredient in concrete, one of the most durable construction materials known to humankind. A paste of cement and water is the glue that binds sand and gravel together into a rock-like mass called concrete, the material of which office buildings, bridges, roads, and sidewalks are made. Cement is manufactured by combining various inorganic materials in the proper proportions. These ingredients are ground together into a fine powder that ensures mixing and improves reactivity. They are then heated until molten in a rotary kiln. The cooled lava-like substance is then ground again to form the powder known as Portland cement. This is how we make cement at Lafarge's Kamloops plant. Limestone, the primary ingredient in the making of cement, is mined here at the Kamloops plant. Mining typically involves removing unwanted materials from the area where the limestone is quarried. This operation is called stripping. Once the hard limestone has been exposed, it is necessary to drill holes in the rock for the explosives. Explosives are used to blast the rock into smaller, more manageable pieces, typically the size of a microwave oven. This operation is called drilling and blasting and is carried out under close supervision. The blasted limestone is then moved by loaders and trucks and dumped into the crusher feed hopper. The limestone is then crushed and screened. The reduction of the rock size is accomplished in a primary and secondary crusher. Rocks up to 1 meter cubed are dropped into the primary crusher where they are broken into pieces 15 centimeters cubed and less. These smaller pieces of rock are then put through the secondary crusher to be reduced even further. All of the broken pieces are collected and passed over a screen, which directs the oversized ones back to the crusher. The screened material is discharged onto a series of belt conveyors and stacked in a long pile called a pre-homogenization pile. Shale and cinerite, which add necessary minerals, are quarried off-site and transported to the plant by truck. They are added in the correct proportions through a feeder onto the pre-homogenization pile. The pre-homogenization pile allows for an approximate chemical mix of raw materials and provides storage. To maintain the highest possible quality, this entire process is closely monitored. We measure the chemical composition of the materials as they are transported into and out of the pre-homogenization pile. A fully automated reclaimer gathers the mixed materials and deposits them onto a conveyor belt for transport to the raw material storage bin. The raw materials are then transported to the next step by feeder belts. Other feeder belts also add iron, silica, and alumina to complete the raw mix. The raw materials are then conveyed via covered belts to the raw mill. The raw materials need to be ground to a fine powder in order to be well mixed and prepared for the burning operation. The materials are ground and mixed together in the raw ball mill. A ball mill is a large horizontal cylinder that is filled about 1/3 full with steel balls and rotated. The steel balls move continuously inside the mill and crush and grind the materials. The raw materials are ground into a fine powder, which is then sized or classified. The finer materials are used in the process, and the rejects of coarse materials are recirculated back to the mill for additional grinding. From the raw mill, the material is conveyed through pipes to the homogenizing silo, where it is blended again to further stabilize its chemistry. Blending is accomplished as columns of high-pressure air lift portions of the fine material, causing it to form an internal circulation and mixing. Raw mill and blend silo discharge materials are monitored for chemical composition as well. The powdered raw material is then conveyed by air to a long rotary kiln. The rotary kiln is the heart of the cement manufacturing process. This is the equipment that is used to transform raw materials into new compounds. The rotary kiln uses intense heat to melt the raw materials. Once molten, the raw materials combine to form a completely new material called clinker. It is this new material, clinker, that is ground into Portland cement. The kiln is essentially a long tube laid on its side at a slight angle, with the feed end being located higher in elevation than the discharge end. The slight angle of the kiln allows material to pass through it as it slowly rotates. The raw material, or kiln feed, travels through 3 zones inside the kiln. The first zone is fitted with hundreds of pieces of hanging chain and is called the chain section. This is where the material reaches its first level of heat at approximately 300 degrees Celsius and where all the water is driven off. The material then travels further into the calcination zone, which reaches a temperature of approximately 800 degrees Celsius and where carbon dioxide is liberated from the feed in a process known as calcining. The material then travels into the clinkerization or lava zone of the kiln, reaching a temperature of 1450 degrees Celsius. It is at this point the materials form the new compounds, which are required to make cement. The metal and glass-like materials actually melt and draw in the calcium from the limestone to form the clinker compounds. The clinker that forms ranges in size from that of beach sand to the size of golf balls and is red hot. During operation, the kiln is fired using a combination of fuels to provide the extreme temperatures required to convert the kiln feed into clinker. The main fuel used is coal, which is trucked into the plant. Coal is ground to a fine powder in a specially designed mill. Fine coal is blown directly from the coal mill to the kiln. The fuels provide the heat necessary to complete the chemical reactions. The hot clinker is then quickly cooled in the cooler by blowing outside air through a set of movable grates. The grates move slowly back and forth, cooling the clinker and transporting it away from the kiln. The hottest portion of the cooling air is recovered and used to save fuel in the burning process. A set of rotating hammers breaks up large chunks of clinker as it exits the cooler. The cooled clinker is conveyed to storage silos or the storage hall where it is stored until used in the finished grind process. Clinker is reclaimed and conveyed to the finish mills, which are very similar to the raw mills. The clinker is mixed with gypsum and crushed into the finished product, Portland cement. Inside the finish mill, steel balls tumble around and crush the clinker into a fine powder. As the cement is ground, it is sent through a separator where the product is sized to separate the fine and coarse fractions. The fines are finished product and are pneumatically conveyed to the cement storage silos, while the coarse fraction is returned to the feed end of the mill to be reground. The finished product is stored in silos until released by the quality control manager after all testing has been completed. Finished cement is a fine, fluffy powder that can be loaded into trucks or rail cars for transport to customers across BC or into the northern United States.